Hello everyone. I hope you have completed ratio proportion playlist. You know that ratio is very important topic of the entire quantitative aptitude section. Today we are going to start with work and time, which is one of the applications of ratio and proportion. So let's get started. We are going to use very few formulas. Like you know that I'm not very big fan of formulas anyways. So in work and time, we'll have the formula. We'll use the formula that is work equal to efficiency into time. Okay, this is the formula which we are going to use. Work equal to efficiency into time. Now, what type of question will you see there? Okay, let's look at some sample questions so you will understand what are we going to learn. So you can see that A can do a piece of work in 30 days while B can do it in 40 days. When A and B are working together, how much time will they take? Alright, then we'll have some more questions which says if A had worked alone, he would have taken 63 hours to complete the task and blah blah blah. Some money is paid to them. What is B's share? Okay, so these are the type of questions we are going to see in work and time chapter. Okay, when group of people are working together, 10 men can complete a job in 15 days, 15 women can complete the job in 12 days. If 10 men and 15 women work together, how much time will they take to complete the job? Alright, so we'll see these kind of questions, and then we have, nevertheless we have pipe and cistern, so we will see some negative work. That means someone is adding into the work, like for example someone is building up a wall, okay, and the other person is destroying the wall, so negative work. Yeah, so this is what we are going to learn in work and time chapter. Alright, so let's get started. So what do we have here? Work equal to efficiency into time. This is the formula which we are going to use. Now let's do some post-mortem of this formula. Okay, so I can also say here, I can also say that efficiency, if I take time to the other side, I can say efficiency equal to work upon time. Efficiency equal to work upon time. Efficiency equal to work upon time. Right? Yeah. And similarly, we will also take some unit of efficiency. Now, time can be in form of minutes, seconds, yeah, hours, days. Okay, it could be either one of them. So we will take the unit of efficiency based on the question. All right. So I hope this part is clear to you. Now in work and time, I have divided the set of questions in multiple parts. Okay, I have defined them in few types. So I will take you through all those types. Now, one of the type is efficiency of individual. So when you see a question where efficiency of an individual is given, then how to handle those questions? Okay, formula is same, work equal to efficiency into time. Now look at that. Look at this. So let's see, you got a question that is A can do a piece of work in 30 days while B can do it in 40 days. A and B together can do it in how much time? Okay, do it in, let me complete, how much time? Although that's definitely it's obvious that we need to calculate the time, right? Okay, now how to deal with this question? Now whenever we have a question which is efficiency of individuals, yeah, efficiency of individual. Efficiency means name of individuals are mentioned. So you can see A's work is given, B's work is given, together work is given. So you got individuals there compared to here group of people. 10 men are working together, 15 women are working together, right? That's a different type. Okay. So in today's class, we'll address this problem, efficiency of individual. All right. So let's see how to do it. Now A can do a piece of work in 30 days, B can do the same work in 40 days. Same work. So first we need to understand what is the work. So let me say the work, let me assume the work equal to X. Okay, let me assume work equal to X. Now when you have this individual people mentioned, so first we will calculate the efficiency of individual. How will we calculate the efficiency of individual? Efficiency equal to work upon time. Efficiency equal to work upon time. So I will say A's efficiency here will be work, which is X, upon time taken by A. So work, A's efficiency will be work done by A divided by time taken by A. So work done by A can do a piece of work which we assume to be X. So work done by A in this case is X. Now time taken by A is 30, right? So that is A's efficiency. So A's efficiency is X upon 30. I will say work per day, yeah, here time is in days. So I'll say A's efficiency is what? X upon 30 work per day, right? Okay. Similarly, we'll find B's efficiency. So B's efficiency will be the work done by A, work done by B. B can do it. Do what? Do the same work in 40 days. So B's efficiency should be X upon 40. X upon 40 work per day. Alright. I hope this is also clear. Now when both of them are working together, in that case they will be working with together efficiency. So together their efficiency will be A plus B, right? So they will be doing X upon 40, for A X upon 30, and for B it's X upon 40. That much work per day. Is that clear? That much work per day, right? Now if I simplify this, let me simplify this. Let me not write like X upon 30, X upon 40. Let me simplify this. So I'll take X common. That's fine. I hope that's fine with you. Divide by 1 upon 30 plus 1 upon 40. You know I am solving the first question of this chapter, so that's why I am writing all these steps. Yeah. And I have told you that if you want to learn shortcuts, first make your foundation stronger. X and simplify, you got 20, 40, LCM 120, here you got 4 and here you got 3. I hope this is clear to you. Yeah, how to add fraction. You remember how to add fraction? We take the LCM of the denominator, which is what? 30 and 40 here. If I take the LCM of this, I'll get the LCM as 120. How to take the LCM? Yeah, let's divide by common number. Let's say if it is divisible by 10, so this will give you 3, this will give you 4, then divide by 3, that will give you 1, it will give you 4. Divide by 4, this will get you 1 and this will get you 1. And then you multiply these 3 numbers and you get the LCM, right? Yes, so LCM, we take the LCM of the denominator, that is 120. Now, to make this denominator, we need to make both of them as 120, right? Both the denominator as 120 here. So to make this part as 120, I multiply here, I multiply by 4. Then in numerator also I have to multiply by 4. Here I multiply by 3. So in numerator also I have to multiply by 3. That's how you get same denominator. 3 4s are 12, so 120. 4 3s are 12, so 120. So denominator is 120. Numerator here, 4 ones are 4 and 1 3s are 3. So I'm explaining the calculation here, and I hope you are aware about how to add the fraction part. Okay, anyways, come back to the question. So question is, in that case, a plus b, the efficiency will be x into 7 by, or rather, let me say 7x by 120 work per day, right? That's the efficiency. I hope this is clear. Now you need to find what you need to find. You need to find time if they are working together. What is time? What will be time formula in this case? Work equal to efficiency into time. So for efficiency we take time here. So efficiency equal to work upon time. If I want to find out, if I want to see time formula in this case, yeah, so time I can say equal to work by efficiency. Work by efficiency, right? Work by efficiency. Okay, I hope this is clear. All right. Now, so time equal to work upon efficiency. Time equal to work upon efficiency. Work upon efficiency. Please do not skip any part of this video, because after showing this detailed solution, I'm going to show you a lot of shortcuts. So do not miss any part of this question, any part of this video. Anyway, so time equal to work. Now, how much is the work? What is the work have we assumed? We have assumed work to be x. We have assumed work to be x, and we need to find out time when they are working together. So we'll definitely take work done together divided by efficiency together, right? Work done together divided by together efficiency. So work done together is what? X. That is the work which we need to complete as per the question. Divide by efficiency is what? 7x by 120. Correct? You remember denominator will go into the numerator. Remember that? Yeah, great. So it's x into 120 divided by 7x. Now you cancel x and x. What do you get here? You get 120 by 7. That's the time taken when they work together. When they work together. I hope this part is clear. Step by step, let's revise. So now when we have the question where we see some individual people, first we'll try to find out the efficiency of individuals. So which type of question is this? You need to identify by looking at the question, and then I will teach you how to identify with more question coming in the videos. So you have individual people mentioned. So we are working on the type of question which is efficiency of individual. When you define the type, it will become easy for you to remember the method, that okay, this is the type of question, this is the method I should follow, right? So what do? First, our job is to find the efficiency of whoever is given, whatever is given in the question. Yeah? If it is A, B, C, D, whoever is given the question, will find the efficiency of all of them. So A is efficiency. Now what is efficiency's formula? Efficiency formula is work upon time. What will be efficiency's unit? Unit will be work divided by the unit of time, right? Time formula will be work upon efficiency. Okay. So work is, we assumed the work to be x. Now A's efficiency is work upon time, B's efficiency is work upon time, together efficiencies. Add both of their efficiency, simplify that, find the total efficiency, and then to find the time together, what we did, we divided the work by together efficiency, right? Yeah, that's what question said. A and B working together can complete it. It means the same work in how much time? So I hope that is clear. Now, what is the learning do we have from this explanation? That's more important. Now tell me one thing, at the end we cancel x and x, right? At the end we cancel what? X and x, correct? So instead of x, had I been assuming y, the solution will remain same. At the end, y and y is going to get cancelled. That means this final answer is independent from the work. Yeah, whatever you assume work in this case, the answer is going to remain the same. Yeah, instead of x, had you been assuming y, you would have got the same answer. Had you been assuming say 100 as a number, you would have got the same answer, right? So this is method number 1. So this is your method number 1, and I hope you are clear with the message which I am trying to give you here, that if you in this type of question where you got efficiency of individual, you need to calculate the efficiency of individual, yeah, where the individual names are mentioned. The final answer, when you will calculate the final time, it is not depending on what work have you assumed. Okay, so the final answer here in this type of question is not dependent on what is the work, what work has been assumed, right? So instead of x we assume y, instead of x we assume 100, you at the end you will cancel that, correct? So this is first type method. Yeah, you can make it easy by skipping some steps also here. Now giving once we have this lesson with us, this lesson shows we can assume any work, right? So with that, with this lesson, this outcome, I will show you an alternate method. Yeah, yes. So alternate method is LCM method. What are we going to call it? LCM method. Yeah, what are we going to call this? LCM method. Okay. Work and time chapter ka LCM method of work and time chapter. Now where do we apply this LCM method? When we have efficiency of individuals, when we have individual people, the name of people mentioned, it's not working as a group of people, 10 men, 30 women, you know, that is a different different type of question. So in work and time chapter, if you got a question where you have name of individual mentioned, we can assume work as x and simplify that, and we can also have another method which is LCM method. Okay, what is LCM method? So as we understood that we can assume anything as work here, the final answer will not change, right? So to make it easy, yeah, why do we have alternate method? To make solutions easy, shortcut. Okay, so you can call this as a shortcut. So if you, with this LCM method is you take the LCM of all given time, yeah, all the given time, you know, whatever time is given for A, for B, for together, whatever time is given in the question, you take LCM of all of them and assume that as work. Okay, take the LCM of all given time and assume that as work. Yes, I hope you are not confused here. This is shortcut. We are trying to understand a shortcut. We are trying to solve the question by LCM method. Okay, you remember this method name, LCM method. So we will assume work as LCM of all given time. So the first method is also fine. I mean, this method is also fine. We can also, you know, get the answer by using the same method in shortcut. What is shortcut? You skip some steps, right? Then you will get the answer in less steps. Whereas here, this is another method. Let's see how do we take it forward. So stay tuned. Yes. Now in the same question here, this is the same question here we have. You got the same question here. And let me solve this question by LCM method. Now here I will take the work equal to, I'll assume the work equal to, let work equal to LCM of what? Time. So here A can do a piece of work in 30 days and B can work the same work. We can do the same work in 40 days. So I will take this time and I'll find the LCM of this. Yeah, so 30 and 40, LCM of both of them. Okay. So what you get LCM of 30 and 40 is 120. So I can assume work as 120. Fine. Now, what is efficiency formula? Efficiency formula, tell me what is efficiency formula? Efficiency equal to work upon time. What is efficiency's unit? Work per time, like whatever the unit of time. So in this case, what will be the efficiency unit? Work upon days, work per day. Okay, work per day, because the time unit is days here, right? Work per day. So what will be A's efficiency? Yeah, A's efficiency. A's efficiency, let me call A's efficiency to be A. Okay, so A's efficiency will be work 120 by time, which is time given, time taken by A, that is 30. So cancel this, what you get? 4 work per day. Are you okay with that? Efficiency of A 120 by 30, 4 work. Efficiency of B, same way, efficiency of B, work upon time. Time taken by B here is 40 days for the same work. That means the 120 units work, 120 units work, right? So work upon time, yeah, efficiency equal to work upon time. So what is B's efficiency here? 3 units of work per day. Yeah, 3 units of work per day, right? 3 units of work per day, right? 3 units of work per day. I hope you are clear. Units of work per day. 3 units per 3 units per day. All right. Okay. Now question said together. Together, how much time will they take to complete the work? So if I want to find the time when they work together, that should be the work, the number of units work they are doing together, they are working on it. Okay, divide by the efficiency together, right? Divide by efficiency together. Tell me what is the answer. Work together, the work which total work which we have assumed to be what? 120, and the efficiency together is what? 4 plus 3. Efficiency together will be A's efficiency plus B's efficiency. Together efficiency what? 4 plus 3. So 4 plus 3 is 7. So the time taken by them will be 120 by 7 days. Unit of time as per the question is what? Days. That's your answer. Is this answer same as the previous answer with the previous method? Yes, it is same. 120 by 7 days, right? So I request you to rewind this video and watch both the methods again. All right. Sometime we are going to use the first method. Sometime we are going to use the second method. So I will teach you how to decide which method to be applied in that particular question, which method you should choose for that particular question, which method will be shorter for that particular question. All right. So I'll teach you that. Don't worry about it. But you should rewind this and then see both the methods again. And if you're clear, let's jump to the next question. What is the type of question we are handling now? What is the type of question in work and time chapter we are handling now? When individual people mention, we first try to find out the efficiency of individual and then go towards the solution. So in such kind of question, to approach such kind of question, first you need to understand what is the efficiency of each one of them. Okay. So next question. A and B can complete a piece of work in 6 days. So are you able to identify this type of question? Which type of question is that? Is it efficiency of individual, or is it a group of people working together? See, group of people means what? 10 men work in 15 days, 15 women work in 12 days. So is it group of people working together? Is that the type of question? No, that is individual people. Yeah, efficiency of individual type of question. Efficiency of individual type of question. Remember the name, efficiency of individual. Okay. So which type of question is this? When I ask you next time such kind of question, you will say efficiency of individual. This type of question. So how do we approach this question? First, we try to find out their efficiency. To find out their efficiency, what is efficiency formula? Tell me, what is efficiency formula? Efficiency equal to work upon time. Work formula, work equal to efficiency into time. Yeah, remember, time equal to work upon efficiency. Remember this formula, right? Remember this formula. Okay. So you can remember this way also. You can write this way also. One circle, and you divide into this way in 3 parts, and you say work, and you have time, and you have efficiency. Okay. So if you want to find efficiency formula, hide efficiency. What do you have? Work upon time. Okay. If you want to find time formula, what is time equal to? Then you hide time, and you get what? Work upon efficiency, right? And if you want to find the work, then you hide work. So if time into efficiency. All right. So that's how you can remember all 3 relation. So note it down this way. Okay. This circle is important for you. All right. Come back. So A and B can complete the piece of work, which we don't know what is a piece of work, in 6 days. A alone can complete the same work in 9 days. Time taken by B alone to complete the same work. So we need to find out the time for B. All right, let's do it. So do you want to do with the first method? Let's solve this question also with both methods. Okay. So first method is method number 1, assuming work as some variable. Let's say if I assume work to be X, in that case A's efficiency is what? X upon time taken by A. A alone can complete the work in 9 days. So A's efficiency is X upon 9. I hope you are okay me not writing the entire sentence. Efficiency of A equal to X upon 9. Why X upon 9? Efficiency equal to work upon time. Work we assume X, time is 9. Clear? Similarly, B's efficiency will be what? That we need to find out. Alright. Okay. But A plus B's efficiency is what? A plus B's efficiency, because question said A and B working together. This is given information. They can complete in 6 days. So I will say A plus B together efficiency is X upon 6. Work done divided by time taken when they are working together. Alright. Okay. Now if you need to calculate for B alone, I should call this to be equation number 1, this to be equation number 2. I should substitute the value of A from equation number 1 into equation number 2. So what do we get here? I get B equal to, you guys will not allow me to use the shortcut, man. Skip steps. If I want to find out for B, I can take this X by 9 other side. So it is X by 6 minus X by 9. Simplify that. So you get B equal to, what is B here? What does B represent in this case? B represent efficiency of B. Remember, efficiency of B. That's what we have taken A and B as, right? So LCM 9 6, LCM will be 36. Okay, how to make this denominator 36? 6 6 are in numerator, also we have to multiply by 6. This 9 4s are in numerator, also I need to multiply by 4. So here I got 6x minus 4x. What is B's efficiency here? 2x by 36. B's efficiency is what? 2x units of work by units of work per day. Time unit is what? Day. Yeah. Now that's not the answer. Question said find the time taken by B. So time taken by B, time taken by B should be equal to work done by B divided by efficiency of B. Yeah, work done by B. Question want B to do the entire work, so that is X divided by efficiency. What is efficiency of B? That is 2x by 36. Yes, denominator will go into numerator. Correct. Simplify. So you got 36x by 2x. Here x cancel. 2 1s are 2, 2 1s are 2, 2 8s are 16. Right. So that's your answer. That's your answer. Yeah, that's your answer. 18. That's your answer. Time taken by B equal to 18 days. Unit of time here as per the question, days. Right. I hope that's clear. And again you can see x and x is getting cancelled. Right. At the end we cancel x and x. So whenever you have this individual efficiency of individual, this type of question, you can also use the alternate method. What is the alternate method? Alternate method is LCM method. Let's see LCM method. Let's see LCM method for the same question. Don't get confused, guys. You need to know both the methods, because sometime I am going to use assuming work as X. Yeah. So you need to know both the method. Don't avoid. Please don't skip this. You have to know both the methods. Okay, so let me solve this question by using LCM method. So in LCM method, what do? We assume work not as X but as LCM of given time, whatever value of time given here. Yeah, for individual, for together, whatever it is. So here 6 days, here 9 days. Learn methods, guys. That will help you. I'm telling you, that will improve your problem solving skills. I have written one article on problem solving skills on my LinkedIn. My name is Shyam Manavat. You can check my LinkedIn account and read that article. That's my opinion. So read. I hope you like it, and you can also comment if your views differ. Anyways, so 6 9 LCM. What is LCM of 6 and 9? 36. Yeah. Right. So I assumed work as what? 36 units. Okay. Now, A's efficiency. What is A's efficiency? A working alone, take 9 days. Efficiency equal to, what is the formula of efficiency? Right. When you are practicing, write formula every time so that you will remember. Efficiency formula is what? Work upon time. How do we remember? Circle, work, efficiency, time. Okay, so time pehle tha. Okay, time, efficiency, one of the same thing, man. You can write efficiency here, time here, is one of the same thing. Okay, so efficiency, hide efficiency, work upon time. Okay, all right. So efficiency is equal to work upon time. Work 36 unit. Time taken by A 9. What is A's efficiency this time? 4 units per day. What is A and B? Question said A and B working together. So A plus B is efficiency. Now what is A plus B's efficiency here? They can complete in 6 days. So it should be work upon time. How much is that? 6 units per day, right? Now if I want to find out for B, the time for B, first of all I should find B's efficiency by substituting A's value as 4 here. अभी एक बात बताओ, simple सी बात, tell me a simple thing. If together efficiency is 6, A's efficiency is 4, so B's efficiency has to be 2. Now what calculation and substitution of value here? Come on, this easy numbers you should be able to calculate on fingertips. So together efficiency is 6, A's efficiency is 4, so remaining efficiency is 2 obviously, so that should be B's efficiency, right? So B's efficiency is 2. Now if B's efficiency is 2, we need to find the time taken by B, that should be work upon efficiency. If I need to find out time taken by B, I cancel time, so what do I have? Work upon efficiency. I hide time, then what is remaining? Work upon efficiency. That's how you can remember. So B's time taken for B is what? Work, which we assume to be 36 units. Time taken by efficiency of B, 2 units per day. Cancel, what do you get? 18. That is time, so 18 days, right? Same as the previous answer. Yeah. So you can use either one of them. So I hope you are comfortable with both the methods. So I will, next questions I will solve only by one method. So whichever is best suitable for that particular question. Okay, and that's how we'll learn how to choose method, which method will work. Assuming work to be X or assuming work to be LCM of given time. So let's look at the next question. Here is the next question. Here is the next question. All right. Question says A and B can complete a piece of work in 18 days. Efficiency of individual. Are you able to identify the type of question now? Efficiency of individual? Yes. Don't worry, when I'm going to solve miscellaneous question, then I will have random arrangement of all the types of question, and then I will ask you that this question belongs to which type. Okay, we'll have that kind of practice set also. Let's come back. So A and B can complete a piece of work in 18 days. I will be using LCM method here. Okay, and I will not be writing all the steps. So I hope you guys are able to tune. You are able to tune yourself with my frequency. So what my method of explanation is fine with you, comfortable to you, and you'll be able to understand which step I am going to skip to make the explanation shorter. So A and B can complete a piece of work in 18 days. So first 18 days is 1, B and C in 24 days, C and A in 36 days. So first of all, I'll take work as what? LCM of 18, 24 and 36. Okay. Now let me tell you how, you know how to find out the LCM, right? Let me tell you here easy way to find the LCM. Okay. That's my way. Okay, when I have small numbers, I use this easy way, not for big numbers. I use it for small numbers. Like these are easy numbers, 18, 24, 36, easy numbers. I take one of the biggest number amongst them, one of the greatest number amongst them. So let me take 36 first. Okay. See, I will tell you the LCM. See, 36 here. Now, when I see the next number 18 and 36, so here this 18 is what? 9 2s are 18, and this is 9 4s are, and 4 is nothing but 2 into 2. So you can see I have taken 18 already. 9 2s is already part of this 18. part of this 36, right? So okay, leave 18, that's not required because that is already part of 36. Then I take the next number 24. All right, this 24 I can split as what, 12 twos are, and 12 is what, 4 threes are. So that is 4 into 3 into 2, that way. Okay, or you can say 2 into 2 into 2 into 3. Okay. Now in this 36 I already have 4 because 4 nines are, and 4 nines are 36. 4 nines are 36, and in 9 I already have 3, correct? So 4 and 3, that's already there, correct? Now this extra 2 which is not there, I will put it here as multiplication. Okay, and that's what gives me LCM. 36 twos are 72. That will get me the LCM. If you do it by your method, you will still get the same answer. So I usually find LCM this way. Don't worry, I will have a separate lecture where we'll be only discussing this method of finding the LCM. Don't worry. Okay, if you understood, great. If not, then you can still go with your method. Okay, but find the LCM. That you have to do anyways. Okay, you have to look at the LCM of these numbers anyways, even if you do go with the method number 1. Now LCM is 72. We got the work. We assume the work as 72 units. Okay. Now we'll go as per the question. Question said A and B can complete a piece of work in 18 days. So what do we do in this kind of question? What do we do after assuming the work? We find the efficiency. We find the efficiency of whatever individuals are given or combination is given. So A and B together take 18 days. So efficiency of A plus B, here is going to be work, which is, now I'm skipping writing the formula step extra. Okay, you should remember now, efficiency equal to work upon time. So efficiency here is efficiency equal to work upon time. So work here is 72 and A and B taking how many days? 18 days. So if I cancel, this is 4 units per day. Yeah, A and B's efficiency is 4 units per day. Let me call this to be first condition. Next is B plus C. So B plus C, here I have B plus C who take 24 days. All right. So B and C's efficiency will be work upon time, right? So this will be 3 times. This will cancel 3 times. So you will have 3 units per day. Okay, that is second. Next is C plus A. C plus A is, now C and A together they are taking 36 days. So work upon time is equal to efficiency, that is 2 times. Are you understanding why? Are you able to catch here why do we assume work as LCM of all of them? LCM is least common multiple, right? So when you have least common multiple of these numbers 18, 24, 36, so they can easily cancel that LCM and you don't have fraction value. Yeah, that is what make this LCM method easier. You won't have fraction value, so calculation become much easier, right? Now understand, A plus B, B plus A is A plus B is 4, B plus C is 3, C plus A is 2, and question said find out about A. A alone can complete the work in how much time? Okay, so we need to calculate time for A. What do we need to find? We need to find time for A. Time for A to complete that entire work. What is the entire work? 72 units. So how do we do this? So now your concept of work and time you have applied. Now you got equations. So now you should know how to solve equation. That's important. How to solve equation. So now the next steps which we are going to do, it's nothing to do with work and time. It is more of how to solve equation. So how do you will have only A from all these three equations? Three equations, three variables. That's the best combination. So what do? We can add all these three equations. That will give me A plus A, B plus B, C plus C. So all of them 2 times. So I can say if I add all of them, I'll have 2 times A, 2 times B, 2 times C. I can take 2 common, and at the right hand side I'll have 4 plus 3 plus 2, 7 plus 2, 9. Correct? So here, by the way, what are ABC? What are ABC? Don't forget, what are ABC? ABC are their respective efficiency that we have assumed. Okay, their respective efficiency. Whose respective efficiency? A's efficiency is A, B's efficiency we assumed B, C's efficiency we assumed C. Okay. So A plus B plus C here, that is 9 by 2, or you can say 4.5. Now if you want to find time for A, we also need to find efficiency of A. How do we do that? We can replace the value of B plus C here. What is B plus C? B plus C is 3. If I replace B plus C as 3, tell me what is A's value? If B plus C is 3, total is 4.5. So how much is left? 1.5. Correct? So A's efficiency is what? 1.5. Can you tell me unit of efficiency? Yes. A unit of efficiency is units of work per day, per time. So here time in this question is days. So A's efficiency you got units, 1.5 units per day. Okay, that's not the answer. You need to calculate time for A. Time for A to complete the work. Okay, so time for A will be total work, which is 72 we have assumed. The efficiency of A is 1.5. Yeah, that's the formula for time, right? Remember that circle? I'm not very good at drawing. So work, efficiency and time. So if you want to find out time, work upon efficiency, right? Okay, now simplify this. What will you get? 72 by 1.5 will get you 48. So time taken by A to complete the job alone will be 48. Okay, 48 days. I hope that's clear. Yeah, and this is one of the important chapter, yeah, this is very frequently asked question, frequently asked concept in any exam. Let's solve one more question. I know this video is becoming little lengthy, but I appreciate your patience. Let's solve this one more question. So what do you have here? Ramesh takes twice as much as time as Mahesh. So Ramesh, Mahesh, Suresh, individual people. So which type of question is it from work and time chapter? This is individual, efficiency of individual, that type of question. So we'll focus on that. So how do we approach this question? First we assume work. Well, but why do we assume work? We assume work so that we can identify their efficiency in the next step. But what if I in any question, what if I get the efficiency values directly? We don't have to assume work, right? Anyways, yes. Okay. So yeah, that's what we do. I hope you are understanding. Why do we assume work? We assume work so that we can find their efficiency and then we can take the question forward. But here they have already given the relationship between the efficiency. See, Ramesh takes twice as much as time as Mahesh. What is the relation now? If I tell you work equal to efficiency into time, okay, so efficiency equal to work upon time. Understand this is very important concept. If time is constant, if I keep time as constant, then I can say efficiency is time is inversely proportional to efficiency. We have just completed proportional chapter. I hope you understand this. That means if efficiency increases, time decreases. That means if efficiency is double, time is half. That means if time is double, efficiency is half. Right? Yeah, efficiency, the proportion chapter which we have completed. That's what I said. I mean, this chapter is one of the applications of ratio and proportion. Okay, come back. So here you have the relationship of time. With the relationship of time, I can directly come to the conclusion of efficiency or relationship of efficiency. Look at this. Ramesh is twice as efficient, take twice as much as time as Mahesh and thrice as much as time as Suresh. So who is the weakest amongst them? Tell me. Ramesh, Mahesh and Suresh. Who is the weakest ones among them? The one who is taking most of the time, right? The one who is taking more time, the highest time amongst all three. So Ramesh take twice as compared to Mahesh. Ramesh take thrice time as compared to Suresh. So Mahesh is the one who is the slowest amongst all, right? He is the weaker one amongst all, right? In that case, you assume weaker's efficiency. Okay. New type of question. I mean, type of question is same, but new. I mean, it's a different of that, where you don't have time mentioned there. It's all a relationship of time. So if I assume Ramesh efficiency is 1, now Ramesh is taking twice as much as time as Mahesh. That means if I relate efficiency of Ramesh and efficiency of Mahesh, if efficiency of Ramesh is 1, then efficiency of Mahesh should be 2. The one who is taking more time should be less efficient, inversely proportional. The one who is taking more time should be less efficient, inversely proportional. Yeah. So if I assume Ramesh efficiency to be 1, okay, Ramesh is taking twice the time. That means Mahesh should be double efficient. Ramesh is taking twice the time. That means Mahesh should be double efficient. I hope you are able to understand this. Now this I am using shortcut. If you want the entire detailed explanation in detail, I can do that also, no problem. But try understanding. I want you to give it an attempt. Let me write this properly. So if time wise, if time taken by Ramesh, if I compare that with time taken by Mahesh, time taken by Ramesh is twice compared to time taken by Mahesh. In that case, if I compare efficiency, it should be reverse. Yeah, why reverse? Because it is inversely proportional. Time and efficiency inversely proportional. It should be reverse. Efficiency of Ramesh and efficiency of Mahesh, if I compare, then efficiency of Ramesh, if I assume 1, the efficiency of Mahesh should be 2. Similarly, comparing Ramesh and Suresh, if question said time taken by Ramesh compared to time taken by Suresh is thrice. Correct? Yeah, that's question said. And thrice as much as time taken by Suresh. So time taken by Ramesh is thrice compared to time taken by Suresh. So if I compare the efficiency, it should be reverse. Right? So in that case, efficiency of Ramesh, if I take 1, the efficiency of Suresh will be 3. Right? Now look at this. Efficiency of Ramesh is 1, then efficiency of Suresh is 3. ratio, if and then relation. Efficiency of Ramesh is 1, then efficiency of Mahesh is 2. Here efficiency of Ramesh, in both cases we have taken 1, we got 1. Yeah, so we can relate Mahesh efficiency and Suresh efficiency also, as in if I say Ramesh efficiency is 1, I got Mahesh efficiency is 2 and Suresh efficiency is 3, right? Yes, perfect. Okay, let's see what else question has. If working together, let me change the color. Okay, if working together they can complete a job in 4 days. Unit of time is days. Yeah, working together they can complete a job in 4 days. All right, okay, we know the efficiency. We can assume the efficiency of Ramesh is 1, efficiency of Mahesh is 2 and efficiency of Suresh is 3. Although it's in relation, but we can assume that, right? So together, now this time work will apply, we'll find out with this formula. We don't have to assume work anymore because we got efficiency relation. Yeah, we used to assume work to find the efficiency relation, but here we already have the efficiency relation. So we can take the work as per the question. Question said working together. So together efficiency is how much? Tell me, what is together efficiency? 1 plus 2 plus 3. That's simple calculation. 1 plus 2 plus 3, come on. 6. How much time are they taking? 4 days. What is work? What is the total work in the units? Work unit will be 6 4s are 24. So we can take work unit 24 units this time. Alright. Then come back to question. Find the time taken by each one of them separately to complete the same work. Okay, 24 units. So what will be the time taken by A? Time taken by A will be total work, which is 24, which we got by using this formula, divided by efficiency of A, which is what? Sorry, not A, Mahesh. Divided by efficiency of Mahesh, that is 1, right? So what did you get? 24 days. Unit of work is 24. Sorry, unit of work is days. The time taken by, what am I doing? Yeah, time taken by Ramesh. I got excited. Okay, time taken by Ramesh is equal to total work divided by efficiency of Ramesh. What is the efficiency of Ramesh? We have taken 1. So divide by 1. Similarly, time taken by Mahesh will be total work divided by efficiency of Ramesh. Efficiency of Mahesh, that is 2. That is, so here you got 12 days. Now you got time taken by Suresh. Efficiency of Suresh 3. So work upon efficiency. Here 8 days. Alright, and you got the answer. 24 days for Ramesh, 12 days for Mahesh, 8 days for Suresh. Right? Great. So you got the answer. Alright. This is it in today's video. In next video, we'll have little difficult question of the similar type. So do watch that video also. My name is Shyam Manavat. I will see you in the next video. Till then, stay happy, stay healthy. Bye bye.